Hello again, business students. Professor Peter Gregory here. This is a solution for Jacob's Chapter 4, Question 7. That's the objective questions at the back of the chapter there. Okay, and I've reproduced that here on my screen, the screen grab of it. The R&D department is planning to bid on a large project for the development of a new comm system for commercial planes. The accompanying table shows the activities, times, and sequences required. Okay, so this is the basis of the most basic type of CPM analysis. I want to get a video to show how to get some of these things done here. For the basic case here, in this example, after you've read the chapter, which I've expected that you have done by now, the activities for this problem 7 are listed A through I, which gives us something on the order of nine activities there. A through I is 9 activities. And a typical chart that's given to us shows dependencies of one activity on the predecessors, and it shows us what the duration of each of those activities is. Okay. So the first part of the problem always is to draw the network diagram. So if we look up top, we have A starts us out, and we have B, C, D dependent on A. And so we have here B, C, and D dependent on A. After that, we have B dependent, or rather E is dependent on B. That'd be E here. And then we have C and D feeding F, where F is dependent on C and D from the chart above. Just looking at the chart above, we get that. G is dependent on D and F. There's our G down here. There's our D and there's our F. It's kind of an interesting sidestep here where D feeds not only F, but it also feeds G. It's kind of an interesting network that they have there. And then finally, H is dependent on D. That comes from here up upper left. And then the last element that we have down there is I dependent on E, G, and H. Okay, so there's I dependent on E, G, and H. Those are where the lines come from, okay? So for every one of our activities, I dropped a little circle in here, wrote in its number, its letter identifier, and then I dropped in what the duration of that activity actually is. So let's go through here and do the early start, early finish path. That's the forward path, okay? So the nomenclature here, I'm going to write, I'll do it down here, is here's your activity. You have a circle here, here's your activity, and we write the early start, the early finish, thusly, and we do the late start, late finish, thusly. Okay, that's how the nomenclature goes. So we work forward to begin with early start times. We're trying to figure out what the critical path is here, but we're also trying to find slack time in here. Which of these activities is there some slack time for? So with A, we're working forward. We go through the early, basically the early version of this, where all the processes start as early as possible. So we start at 0, and we add 3. We move the 3 of the early finish to the early start of the following processes, okay? 3 weeks, start on the 3rd week, takes 2 weeks, and end on the 5th week. Start on the 3rd week, takes 4 weeks, takes us to the 7th week. Start at the 3rd week, takes 4 weeks, we end up at the 7th week. And so notice that C and D are in parallel, and so far they're tied, okay, for 7 weeks. But the path from A to B is a little bit shorter. It's 2 weeks shorter. Okay, so this is what we're after. Now we notice that there's something going on here with these activities. All right, so I'll take the early finish time of B goes to the early start of E. So we move 5 there. 5 plus 6 is 11. Okay, and we have to wait here for a little while. Okay, because what we need to do is work the rest of these paths, and we need to look. The feeder to I is activity E, G, and H, and we have to look at how long it takes to get through here. We're looking for the longest time, basically. And the longest time as we work forward is going to delimit how soon we're ever going to be able to get done with the entire activity, with all the activities with I, okay? All right, so C and D are tied at 7. So that means they both feed F, and so F can start at 7 from the outputs of C and D, okay? So G is dependent on F and D. We have to wait a little while here before we do this because we have to calculate 7 plus 6 is 13. Okay, so this finishes at the 13th week. This feeds G, but it finishes at the 7th. And so we take the longest of the times of the predecessors, and that's 13 weeks. Okay, see, we can't start G at 7 because it's going to take 13 weeks to get all the way through F6. So that's the longest pole in the tent, so to speak. The longest time here sets up the following activity, okay? Now, H is only dependent on D with no real decision factor there. We could just write in it's 7, okay? So it finished at 7. We can start H at 7. H feeding I. We're looking for what's the latest finish time for the predecessors, okay? So 13 plus 2 is going to be 15, and 7 plus 3 is going to be 10. So of E, G, H, the longest path through here has taken us out to 15 weeks. We can't start this one until 15 weeks. That's as easy as it is. And what did we have? I was 3 weeks. We had not written that in there. There's 3. So 15 plus 3 gives us 18 weeks. Okay, so that's the longest path through here gives us 18 weeks. So let's look at the paths that we have so far. So we have A, B, E, and I. We have A, C, F, G, I. We have A, D, F, G, and I. We have A, D, G, I. And we have A, D, H, I. Okay? And what we can see here is the A through these parallel paths C and D to F to G to I gives us 18 weeks. That's the critical path, all right? We have to hit those numbers. We can't slide any of the activities on the critical path. They all have to happen right on time to our forecast, or else we're going to be late if we told the customer 18 weeks up here, okay? So the time through here would be 18 and 18. We actually have dual critical paths, 2 of them, okay? So that would be the answer for B. What is the critical path? We have the 2 that I just mentioned there. Okay, suppose you want to shorten the completion time as much as possible. Okay, before we do that, let's finish our analysis. So now we have to go through and we have to look at the late finish, late start. And I said them on purpose because we're working backwards through the net. Okay, so it says the late finish here, there's no slack time at all to get through our entire proposal to our customer here. So we drop the finish time from the early finish down to the late finish. We can't end any later than 18 or we're going to be behind. So we drop that down to the late finish. And now we start working back through the network. So 18 minus 3 is 15. Okay? So we don't have to finish E until the 15th week, or G, or H. And you're going to notice something, that we're starting to see that the numbers above and numbers below, when they're different, there's slack time there. That's an early indicator that we're going to be able to slide E around a little bit here, because the first time through we tried to start everything absolutely as early as possible. And the reason we're going through backwards now is to see how late we can start anything here. So to finish on the 15th week, we'd subtract 6, we get ourselves 9. Okay, so if we can start as late as the 9th week. We have what, 4 weeks difference between early start and late start, and we can start E anytime in between there and still come out at the right time. That's why we're looking for the slack time there. Okay, so now we have I. We're going to work backwards here. We dropped our 15s down here. And we'll notice that on the critical path here, that the early finish and the late finish are the same, which makes sense because that's the critical path. We're not allowed to slide times here. And we're going to have to be careful working back through here, okay, that on their critical paths, the numbers above are going to match the numbers below. That's a characteristic. By definition, there's no slack time in there, okay? So 15 minus 2 is 13 here. So we can start this one as late as 13, minus 6 is 7. Again, it's on the critical path. These numbers have to meet, or they have to match in the critical path here, okay? Let's see, okay, so 15 minus 3 is 12. Okay. So now we need to take, going back to the predecessors here, we need to take the latest time that we have of the following activities here, okay? Let's start up above. For the easy one, we can start B2 as, well, we can finish as late as week 9, take 2 is 7, okay? And again, we have 4 weeks of slack time for B2, and we have 4 weeks of slack time for process E. Okay, you can get that rate from the early numbers to the late numbers. There's a difference of 4 weeks. We have 4 weeks of slack time in there. Okay, all right. So we know now we have to go back here to our critical path. This necessarily has to. We're going to drop here. Here's our late finish. We have to drop that back into both this spot and this spot. Okay. And we can see that we have some slack time here, 13:15. We have slack time here at H is where we have slack time, okay? Because G was on the critical path, right? Okay, so we had G on the critical path. That has to match, the top numbers have to match the bottom numbers, and we had some slack time in H3 here. So we dropped 13 back here. And by our analysis, we had to finish C4, D4 by week 7. Let's work backwards from activity C. 7 minus 4 is 3. D, you get the same outcome here. 7 minus 4 is 3. We drop our 3. Now we're moving our late start to the late finish, and subtract 3 is 0. And that's how we finished the analysis going backwards for the late times. And the reason that you think about it a little bit, what we've done is we've just tried to start every process as late as possible. And in our critical path, nothing changed because there is no wiggle room. But we do have wiggle room through our northern route here and through our southern route. Okay. Okay, so now we take a look at C. Suppose you want to shorten the completion time as much as possible, and you have the option of shortening any or all of B, C, D, G. Which would you shorten? Okay, so this is going to be a question about, are we on the critical path or not? Okay, so it doesn't help us to shorten B at all because it's not on the critical path. Now, if we shorten C, nothing's going to change because it falls off the critical path. If we took a week off of C, D is still hanging out here. Okay, so D is still at 4. And we still have a critical path. We're trying to buy a week so we can finish on the 17th week. That's the nature of the question, right? Okay. So should we get rid of C or D or G? And if we look at G, okay, suddenly we see that by just shortening G from 2 to 1 week, that indeed is on a singular path on the critical path. And if we strike off a week here, because of the way that this network works, coming out of G, we're driving the start time of I, and so this would end up being 14 and 14. This would start at 14. This would be 14, and 14 either way, plus 3 is going to be 17 weeks. So that's how we figure out how to chop out a week of the schedule. You can't do it with C or D. You'd have to take a week off of both of them. Okay? And what is the new critical path and earliest completion time? Well, we pretty much just calculated that, and because G is on a single part of the critical path, we only reduce this by 1 week, but we still have 2 critical paths, and that should be the solution for problem 7.